Let us solve example 2. A departmental head has 4 subordinates. So there is a head of the department and 4 persons are working with him, and 4 tasks to be performed. There are 4 jobs to be performed. The subordinates differ in efficiency. So the efficiency of 4 different persons is different, and the tasks differ in their intrinsic difficulty. So the tasks or jobs are also different. His estimate of the time each man would take to perform each task is given in the matrix. That is, the departmental head, his estimate of the time each man will take to perform each task is given in this matrix. So the cost matrix gives you the time taken by these 4 persons to perform these 4 tasks. So for example, 18 minutes, suppose this is a time to take to perform this task A by the first person E is 18 minutes. Similarly, 26 minutes is the time required for this person F to perform the task A, and so on. So the cost matrix represents the time required to perform these 4 tasks by these 4 persons. Now, how should the task be allocated? One to a man, that is, each task is allocated to one person. One person will be allocated one task. So how should this assignment we should make to minimize the total man hours? That is, find an assignment which will minimize the time taken by these 4 persons to perform these 4 tasks. So let us solve this assignment problem. First step in the Hungarian technique is subtract smallest element of each row from all other entries in that row, starting with the first row. Apply this step 1. Select the smallest element and subtract it from all the entries in that row. So consider the first row now. Now, consider the first row. In this first row, the smallest entry 18, 26, 17, 11, these are the entries. So smallest entry is 11. Subtract 11 from all the entries in the first row. So 18 minus 11 is 7. 26 minus 11 is 6 minus 1 is 5 and 2 minus 1 is 15. 17 minus 11 is 6 and 11 minus 11 is 0. Then second row, the smallest element is, these are the elements 13, 28, 14, 26. The smallest number is 13. Subtract 13 from all the entries in the second row. So we get 13 minus 13, 0. 28 minus 13 is 15. Then 14 minus 13 is 1. 26 minus 13 is 13. Now third row, 38, 19, 18, 15. Smallest entry in the third row is 15. Subtract 15 from all the numbers in the third row, we get. So here 15 minus 15 is 0, 18 minus 15 is 3, 19 minus 15 is 4. Now 38 minus 15, 8 minus 5 is 3 and 3 minus 1 is 2, 23. Then fourth row, the smallest entry, these are the entries 19, 26, 24 and 10. Now subtract 10 from all the entries. 19 minus 10 is 9. 26 minus 10, 16. 24 minus 10, 14 and 10 minus 10 is 0. So first step we have applied. First step, subtract smallest number of each row from all the entries in that row. So we have performed step 1. Subtract minimum element of each row from all other elements in that row. So this is a matrix obtained in the first step. Now second step, repeat step 1 for columns. That is, starting with the first column. Starting with the first column, there are 4 columns. First column, second column, third column, fourth column. Starting from the first column, select the smallest element and subtract from all the elements in that column. So let us perform this second step. So step 2, repeat step 1 for columns. Now look at the first column. In the first step, what is the smallest entry? Smallest entry is 0. Subtract 0 from all the entries, so elements will not change. Here we get 7 minus 0, that is 7 as it is. 0 minus 0, that is 0. 23 minus 0 and 9 minus 0. Now second column. Here, smallest entry is 4. Subtract 4 from all the entries in the second column. So 14 minus 4, we get 11. 14, sorry, 15 minus 4 we get 11. 15 minus 4 again we get 11. 4 minus 4 we get 0. And 16 minus 4 we get 12. Then look at the third column. Smallest entry is 1, subtract 1 from all the other entries in the third column. So 6 minus 1 is 5, 1 minus 1 is 0, 3 minus 1 is 2, 14 minus 1 is 30. Then in the last column, fourth column, smallest entry is 0, so subtracting 0 will not change the elements in the fourth column. So we get 0, 13 minus 0 is 13, 0 and 0. So this is a second step. Then we move to the third step. That is cover all zeros with minimum number of horizontal and vertical lines. So here this is step 2 plus step 3. So we now we make an assignment, and while making an assignment we will draw horizontal and vertical lines. We begin with the rows. First row, and we look at the rows containing single 0 first, and we will make assignment there. All right. So look at the first row. There is a single 0. Make an assignment in the first row. So while making an assignment in a row, we will, this is an assignment in a row. So we will draw a vertical line. That is, we will cross this column when we make an assignment in a row. So we will cross other zeros, drawing a vertical line. Now look at the row number 2. Now there are 2 zeros. We will use it later. First look at the row containing single 0. Now third row. Now third row, 1 0 is already crossed. Now this is a 0 left in the third row. It is a single 0 now in the third row. So we make an assignment here and draw a vertical line. Draw a vertical line in second column. All right. Now look at the fourth row. There is no single 0 in the fourth row. Now, if you look at the row, there are 2 zeros now in the second row. We will see it later. Now, consider columns now. Starting from the first column, look at the single 0. Now, if you look at the first column, there is a single 0 here. So, we make an assignment here in the first column. And when we make an assignment in the first column, we will draw a horizontal line here. All right. So an assignment is made in the first column. Second column, there is already an assignment is made here. Now in the third column, no 0 left. In the fourth column, no 0 left. That is, all zeros are covered by these 3 lines. 2 vertical lines and 1 horizontal line. All zeros are covered by these three lines. So how many lines we are drawn to cover all zeros? So this is a first step. Cover all zeros with minimum number of horizontal and vertical lines. So this is if we have applied step number 3, cover all zeros with minimum number of horizontal and vertical lines. Now we apply step number 4. So what is step number 4? Let us see. All right. So this is step number 4. Subtract the lowest uncovered number in the matrix from all the uncovered numbers. So what is the smallest uncovered number? Look at this matrix in the step 3. Now uncovered means the number which there are two lines, vertical lines, one horizontal line. The numbers which do not lie on these three lines are uncovered numbers. So 7, 5, 23, 2, 9, 13. These are the uncovered numbers. Other numbers are covered numbers, covered by these three lines. So what is the smallest uncovered number? Smallest uncovered number is 2. This is a smallest uncovered number. So subtract it from all the uncovered numbers. So 7 minus 2, 5 minus 2, 23 minus 2, 2 minus 2, 9 minus 2 and 13 minus 2. We have to subtract it from these uncovered numbers. Then next sentence is add the same number, add it to the numbers which are on the intersections of horizontal and vertical lines. So look at the intersection of horizontal and vertical lines in this matrix here. This 13 in this second row is a number in the on the intersection, and this 11 is also a number which is on the intersection. So two numbers are on the intersection of horizontal vertical lines. We have to add 2 to these, add this smallest number 2 to 11 and 13. And what about other? And do not change other numbers. This is a procedure, algorithm in step number 4. So what is the step number 4? Select the smallest number. Here smallest number is 2. Smallest uncovered number is 2. And subtract it from all the uncovered numbers, add it to the numbers which lies on the intersection. So we will add 2 to these two numbers 11 and 13 and do not change other numbers. And why we are using step number 3? Because in the step number 3 we do not get optimum solution. That is, what is the criteria? The number of lines Here, how many lines we have drawn? 3 lines, 2 lines, vertical lines and 1 horizontal line, and it is not equal to order of the matrix, which is 4. And if it is 4, then we get solution in step 3, but it is not, the number of lines are not 4. So this is not the optimum solution. Optimum solution is not reached. That is why we are using step number 4. All right. So look at the matrix now. The smallest uncovered number is 2. So we apply step number 4. So 7. So we have to subtract 2 from all uncovered numbers. So 7 minus 2 is 5. We get 5 here. Then this 5 is the uncovered number. 5 minus 2 is 3. All right. These are the numbers on the line. We want uncovered number. So 23 is the uncovered number. So 23 is in the third row. So 23 minus 2, we get 21. 9. 9 minus 2, we get 7. All the numbers in the second column are covered. All the numbers in the second row are covered. Uncovered numbers are here 2 and 13. Now 2 is in the third row, third column. So 2 minus 2 we get 0, and 13 minus 2 we get 11. So we have subtracted the smallest uncovered number 2 from all the uncovered numbers. Then add the same number, add it to the numbers which are on the intersection. What are the numbers on the intersection of horizontal and vertical line? 11 and 13. These two numbers lies on the intersection. So 11 is in the cell second row, second column. So 11 plus 2. So here we increase this number by 2. Similarly here 13 plus 2. It is in the fourth row, second row, fourth column. So 13 plus 2, we get 15. So we have added 2 to the numbers which are on the intersection. What about remaining numbers? Do not change other numbers. The numbers on the lines, other numbers on the lines will not change. So 0, 0, 13. Sorry, 13 is on the intersections. This 0 is not on the intersection, this 0 is not on the intersection, but it is on the line. So we keep these numbers which are on the line but not on the intersection as it is. Now second column 11 is as it is. This is on the intersection, so we have added 2, 0 and 12 as it is. Then last column 0 as it is, we have added 2 on the intersection and these 2 zeros as it is. So this is step number 4 we have applied. Now then apply step 3 again. So we have to apply now step 3 because you will get solution in step number 3 when the number of lines are equal to order of the matrix. So again, what we will do, starting from the first row, select a row with single 0. So first row contains single 0. Make an assignment. We are applying step number 3. So when we make an assignment in a row, we will cross that column. All right. Now there are 2 0 in the second row, 2 0 in the third row. There is no 0 in the fourth row. So we will first consider single zeros in a row and column. Now second row contain 2 0, third row contain 2 0. Look at the columns now. First column contains single zero. So first column we make an assignment, and when we make an assignment in a column, we will draw a horizontal line. Now, second column, 11. So there is a single zero here in the second column. So we make an assignment in the second column. So we have to draw a horizontal line. Third column does not contain single zero. Fourth column there is an assignment. Now we have covered all zeros, no zero left. All zeros are covered, that is they lies on these three lines. So how many lines we have drawn? Again, number of lines, horizontal and vertical lines. We have drawn three lines, two horizontal, one vertical, and it is not equal to order of the matrix, which is 4, order of the cost matrix, which is 4. That is 3 is not equal to 4. So what is the procedure if you don't get optimum solution in the third step? So we apply step 4 repeatedly. 4 and third, these two steps are applied repeatedly. We apply these two steps repeatedly. So what is step number 4 again? Look at the matrix, this first matrix, and select the smallest uncovered number. The smallest uncovered number. In this matrix is 5, 11, 3, 7, 12, 11. What is the smallest? Is 3. So subtract it from all the uncovered numbers. So 5 minus 3, 11 minus 3, 3 minus 3, 7 minus 3, 12 minus 3, 11 minus 3. Add it to the numbers which are on the intersection. What are the numbers on the intersection? Here it is 15 and here it is 0. We have to add 3 to these two numbers and do not change other numbers. So this is a step number 4. All right, so we will apply step number 4. The smallest uncovered number is 3. Subtract it from all the uncovered numbers. So 5 minus 3 we get 2. 11 minus 3 we get 8. Then 3 minus 3 we get 0. We have to subtract it from the uncovered numbers. Do not change the numbers on the line. So we keep 0 as it is. This 0, 13, 0, these are the numbers on the lines. 15 is on the intersection. So we have to add 3 to the numbers which are on the intersection. So 15 is a number. So 15 plus 3 is 18. Third row 2100, these are the numbers on the line, do not change these numbers. 0 is on the intersection, so we have to add 0 plus 3 is 3, and 7, 12, 11 are uncovered, so we have to subtract 3 from the uncovered number. So 7 minus 3 is 4, 12 minus 3 is 9, 11 minus 3 is 8, and 0 is on the line, so do not change it. All right. So this is a matrix, cost matrix obtaining step number 4. So after step number 4, we apply step number 3. So we now apply step number 3, apply step number 3 of Hungarian technique or Hungarian method. So what we will do, a matrix, this is a cost matrix obtaining step number 4, on which we are applying the step number 3. Look at the row, that is we have to cover all zeros with minimum number of horizontal and vertical lines. So look at the rows containing single zero, say first row contains 2 zeros, second row contains 2 zero, third row contains 2 zero, and fourth row contains single zero. So we make an assignment here, right? So while when we make an assignment in a row, we have to cross that column, then so we have made an assignment in the row number 3. Now if we look at the row, first row contains single zero, we can use it. Second row there are 2 zero, third row contains 2 zero, so we can make an assignment in the first row. But let us make an assignment in a column, because we have started with the first row, there are 2 zeros, second row there are 2 zeros, initially there are 2 zeros in the third row, and fourth row. So we, from the first to fourth row, we have make an assignment in the fourth row. Now look at the columns. First column contains single zero, this is a assignment in a column. So we draw a horizontal line because we have made an assignment in a column. Now look at the second column. Again, there is a single zero in a second column. So we make an assignment here and draw a horizontal line. Look at the third column now. So two zeros are already crossed. So there is a single zero now. We can use it for an assignment and draw a horizontal line. So in this way, we have drawn the horizontal and vertical line. So we get three horizontal, one vertical, 4 lines. So this is the optimum solution. We have obtained the optimum solution. So the number of lines, how many lines we are drawn? 3 horizontal, 1 vertical, 4. It is equal to order of the matrix, which is 4. So therefore, by Hungarian technique, the optimum solution, optimum assignment is obtained. So what is the optimum assignment? Therefore, this solution, this is an optimum assignment. And what is the optimum assignment? So first write down the assignment. What is the assignment? Task A, B, C, D, and these tasks are assigned to which main. So this is an assignment. A is assigned to G, that is C13 is the assignment cost. B is assigned to the first person E. C is assigned to F. That is C is assigned to this person F. It is an assignment in the third row, second column, and in the fourth row there is an assignment in the fourth column, that is C4 4 is the cell in which we have made an assignment. So B is assigned with H, last person. So this is an assignment, optimum assignment. There is no zero left or what we observe. So this problem does not have an alternate solution. There is no choice of assignment. Each row, while we have made an assignment, we observe that we have started an assignment in a row containing single zero and in a column containing single zero, and we get only one zero when we made an assignment. We do not have any other choice left. So we have used that single zero for an assignment and we observe that there is no other choice. So this problem does not have an alternate solution. So what is the optimum, that is minimum assignment cost? So here the optimum or minimum assignment cost is so look at the cell in which we have made an assignment. In the first row, the assignment is made in the cell C13. So what is the cost of assigning job A to the main, that is what is the cost of assigning this task A to the person G? So this cost is given in the original matrix, cost matrix. So C, we will take this cost C13. What is C13? Then we will take this cost, the cost of assigning this job B to the person E is C12. So first is C13, then 21, C21. First, let us take C31. C31. What is C31? In the first matrix, C31, sorry, C13. So job A is assigned to the job B and the cost of assignment is 70. C13 is 70. So this is C13, that is assignment in the cell, first row, third column. The cost of assignment is 17 and the cost of assignment of this task to the person F is C, given in the cell C21, C21 in the original cost matrix. C21. So job B is assigned with this person E and the cost of assignment is this 13. So let us use it, 17 plus 13. Then next task is C is assigned to the person F and the cost of assignment is in the cell C2, C3, 2 in the original matrix, 3, 2, C3, 2, that is 18 is the cost. So plus 18, and for the last job, the assignment is made in the this cell, that is it is in the fourth row and fourth column, C44. The cost is 10 in the original matrix. The cost of assigning task D to the person H is 10. So what is the sum now? 17 plus 13, 30, 30 and 40, 50 and 58. 58 is the minimum assignment cost. Now in this matrix, cost means the time taken by these four persons to perform these four tasks. So when these four persons perform these four tasks, this 58 minutes required minimum. This is a optimum assignment. That means when we assign these four tasks with these four persons G, E, F, H in this manner, the cost of assignment, that is the minimum time will require to perform to complete these four tasks. So we will assign the task A to the person G, task B to the person E, task C to the person F, task D to the person A. In that case, the minimum time will require to complete these four tasks.